Guys, we are doing AAT notes on 1.3, which is graphing inequalities. You should be familiar with this from your algebra classes, so we will zoom through it pretty quick. So remember here, linear inequality is not a function. However, you can use linear functions to help graph linear inequalities. When you see an inequality with a greater than or equal to or a less than or equal to, since it's equal to that line, it'll be a solid line that you graph. Whereas if you have just a less than or a greater than without the line underneath it, you're going to dot your line because it's not actually equal to that line. It goes all the points right up next to it. Then we're going to plug in a point to do a true false test. If we we can choose any point we want to, but 0, 0 is a good choice as long as it's not on the line, and we plug it in. If the result is true, we shade that area that contains the chosen point, and if it's false, we shade the other area. Okay, so we're going to start with graphing 2x plus 6y equals 12. So this is in standard form. So when we are in standard form, we know that the slope is opposite a over b. So in this case, that would be negative 2 over 6, which is negative 1/3. So that's helpful. The y-intercept, remember we plug in 0 for x. If we plug in 0 for x, we're essentially just covering it up. We get 6y equals 12. So divide by 6, and we would get y is 2. So that's 0, 2 for the y-intercept. If we cover up, if we want the x-intercept, where y is 0, we cover up the y. We get 12y equals, 2y equals 12, divide by 2, and our x-intercept is 6, 0. So that gives us more than enough information to graph this line before we think about where to shade. 0, 2. For the y-intercept, 6, 0. For the x-intercept, it is equal to, so it is a solid line. So I'm going to get my ruler, make a solid line there, and then I'm going to do my true-false test. So, true-false test. I'm going to plug in the point 0, 0. Since 0, 0 is not on that line, if I plug in 0, 0 to the equation, 2 times 0 plus 6 times 0, and see if it's greater than 12. Well, that would be, of course, 0, which is not greater than 12. Nope. So I don't shade where 0, 0 is. I shade above the line. So we're just testing to see if it's true. We could test with any point. I could plug in another point if I wanted to. Say if I chose to plug in the point 1, 2, 3, 4, 0, 4. If I tested the point 0, 4, I would get 2 times 0, plug it in this equation, plus 6 times 4 is greater than or equal to 12. And I'm going to put question mark because I'm testing it. I get 0 plus 24, so 24 is greater than 12. That's true, so I should have shaded where that point is, and I did, so I'm looking good. I only have to test one point, but sometimes it's good to double check with the second point. So line number 2, let's let you try it. Pause the video right here and give it a try, and then I'm going to give you the answers. So for example number 2, here is your line. Our x-intercept came out to be 4 by covering up. 3x equals 12, so x equals 4, 0. Our y-intercept, if I cover up the x, I get negative 3 for the y-intercept. The slope is negative a over b, which would be negative 3 over negative 4, which I could use also if I wanted to. Don't have to. So I plot the 2 points, negative 0, negative 3, and 4, 0. I plugged in 0, 0, and I got 0 is less than 12, which is true. So I shade where that 0, 0 is. Not hard at all. Okay, flip on over to the next page. This one I think is even easier, example 9, because this is y equals mx plus b. Notice that is not equal to this time, so we are going to dot that line. So our y-intercept is -5. So we always start with the y-intercept if we can. 1, 2, 3, 4, 5. Our slope is 1/2. So we're going to rise 1, run 2, rise 1, run 2, as many times as we want to. This is supposed to be a dotted line. So I'm going to dot it. Dot, 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 dot. Still goes forever. Now I'm going to do my test. I'm going to plug in 0, 0 to that equation, and I get is y greater than, question mark, 1/2 times 0 minus 5. Now I shouldn't have put y. I'm plugging in 0, 0. So I'm plugging in 0 for y and 0 for x. So is 0 greater than -5? And think about this. Sometimes I see people write all this right and they don't actually think. 0 is greater than -5. That is true. So I'm going to shade in the area where 0, 0 is, which is above the line. I could check with a second point. Okay, so on this one, I have x is greater than. Be careful, that looks like y equals mx plus b, but it's not. So to get it in the right form, I'm going to subtract y to the other side. And I get -y plus x is greater than -3. And I'm going to subtract x over to this side. And I get -y is greater than -x minus 3. And then I can't have a negative here. Remember, when you divide the equation or multiply everything by -1, if you multiply an inequality by a negative number, you've got to flip that. Now, when I first looked at this, I thought it'd be a lot easier just to bring the 3 over to the other side. So if you notice that, but a lot of people don't, you would end up with this. But be careful, notice y is on the less than side. So either way, but your equation is y is less than x plus 1. So the slope is 1, the number in front of x, and the y-intercept is also 1, 0, 1. So we're going to start with that y-intercept 0, 1. We're going to use the slope up 1 over 1, up 1 over 1, up 1 over 1. Decide if it's dotted or solid. It is dotted because it's not equal to. So I'm going to use my ruler and dot that line. It does not go through the point 0, 0, so I'm going to plug in the point 0, 0. So 0, I'm going to plug it in always the original, just in case you made a mistake somewhere along the way. 0 is greater than 0 minus 3. I'm trying to see if this is true. Is 0 greater than -3? Yes, it is. So I am going to shade where 0, 0 is, which is below the line. Nice job.